Good afternoon, everyone. I am a biostatistician, and I study how data shapes medical decisions when stakes are high. Today, I wanted to share two stories about food, medicine, and belief. So what does high stakes really mean? When facing cancer, patients are making decisions in the middle of fear, urgency, information overload, and uncertainty. When decisions are made under that kind of pressures, evidence isn't optional, it's essential. That's where statistics comes in. As a biostatistician, I don't treat patients directly. I work behind the scenes. My job is to ask testable questions, design studies, and separate signals from the noise. That work may sound technical, but it truly shapes the decision patients ultimately face. Let me explain through two stories. So the first story begins with very simple questions. What should a cancer patient eat? For decades, blood cancer patients were told to follow strict neutropenic diets that patients very much disliked. No raw fruits, no fresh vegetables, everything's cooked. It's not popular. This diet was created to protect the patients with weak immune systems, and the patient couldn't fight infection the way healthy people can. The term neutropenic comes from neutropenia, medical conditions, low white blood cells. And during the chemotherapy or stem cell transplantations, those cells are suppressed. When that happens, the infection risk rises sharply. Many serious infections begin in the gut, and also uncooked food carries microbes. Then the chemotherapy damages mucosal lining of the gut, which allowing the easier invasion of gut microbes into the bloodstreams. So the logic seems to be clear. Reduce exposure, reduce risk. So over 50 years, this diet has been the standard of care. Well, over time, however, earlier studies begin to suggest something different. They showed little difference in infection risk, and patients reported worse quality of life under strict restrictions. So hospitals, as a trend, gradually loosened the rules and allowed more food freedom. The assumptions about this shift were very simple. If we liberalize the diet, the quality of life improves, nutrition also improves, yet the infection risk stays the same. It sounded reasonable, but we really needed data. So a new study asked a simple question. What actually happens if cancer patients are allowed to eat more freely? So in a large controlled clinical trial, over 200 blood cancer patients were randomly assigned to either strict neutropenic diet or a more liberalized diet, including fresh food. The primary endpoint was the major infection rate. After first interim analysis, the data, however, made us feel uneasy. Not definitive, but concerning. This was where statistical leadership mattered. We don't overreact, but also we don't ignore the potential safety signal. So we ask basic questions. Is this real? Is it random noise? And should we continue or stop given this early stage of data? Instead of waiting for the next scheduled interim review, we recommended adding additional interim analysis sooner because we wanted to take another look at the safety before exposing more patients. Well, the extra look made the picture clear. The safety signal persisted, and we had to make hard decisions. We started the trial earlier because it was our responsibility to protect the patients from unnecessary risk. The final result very surprised us. The liberal diet led to a higher infection rate. There was no improvement in nutrition, had no improvement in quality of life. So the expected trade-off never appeared. We recently able to publish this final analysis, and they have started to have a broad impact, sparkling national conversations. It clearly indicated the assumptions we had were not evidence. Today, my second story begins with a different kind of questions. Could anti-parasite drug treat cancer? Ivermectin is an anti-parasite drug. For humans, it is available only by prescriptions. For animals, it can be purchased over the counter. Recently, it has gained a lot of attention online as a possible cancer treatment. Some patients are taking it, hoping it may help. While this is not standard of care, why does it spread? First, laboratory studies showed possible anti-tumor signals. Then online testimonials, including Mel Gibson, amplified the attention. And social media, of course, moves faster than scientific research. This is very understandable to me because hope spread quickly while evidence moves carefully. So what do we know about ivermectin at this moment? Number one, there are no rigorous randomized clinical trials showing ivermectin cures cancer. Number two, most available evidence comes from laboratory or early stage small-scale studies. Laboratory findings are important, but they are not proof in patients. Correlation is not causation. This graph with the real-world data shows almost a perfect correlation, but no one believes consumption of margin causes divorce in state Maine. Likewise, when a patient improves while taking something, we ask, was it a drug? Or was it standard therapy? Was it natural variation? This is why and when randomized trials existed. Causal inference protected patients from false hope. So what are we doing right now? Statisticians and oncologists are formed to investigate electronic medical record real-world data in Florida. We are asking, who is taking ivermectin? What outcomes are we seeing? And what can we possibly conclude? Careful analysis comes before strong claims. In both stories, the role of statistical leadership is the same. From the testable questions, we quantify risk, evaluate benefit, measures uncertainties, challenge assumptions, and we communicated with the scientists and the public. Statistics is not just mathematics. When the questions matter, really matter, statistics is how we find the answer. Through both stories, I have shown that data-informed evidence should shape the cancer treatment, not trend, not celebrity endorsements, and not assumptions. Good recommendations should be grounded in data, expertise, and in careful analysis. There is one more reason why this matters. Behind every data set is a patient, not a variable, not a data point. Every data we analyze represented somebody's story, possibly including your family and my family, their struggle, their hope, and their life. This is why rigor matters and why our belief should be supported by science. Thank you.